Okay, welcome in. In this video, we're going to be talking about the rule of 72, which is a very cool, kind of unique result in finance. We're going to be doing that and exploring it in R. So I have my script open here, and the first line, I'm setting R equal to 0.02. This is saying our rate of return is going to be 2%. And you can think of this as like a savings account that gives you 2% a year. At the time of making this video, it would be hard for you to find a savings account that gives you 2% a year, but maybe, in the future, the economic conditions are different. This is high. Now we're expecting much less. But let's say, again, you put your money away with the bank and the bank pays you 2% a year on what you save with them. And let's say you save for 40 years. So this year is 40, and let's say you start with $100. Simple. You put $100 in the bank for 40 years at an annual savings rate of 2%. Just to review, that means after the first year you have $102 because we have 100 times 1.02, which this is basically saying we get what we put in plus 2%. That's $102. After 2 years, the way we do this is we square our 1.02 because this is compounding interest. Basically, if I run this, I'm going to see we get $104.04. Basically, we don't just get $2 additional from the original 100. After the first year, we have $102. So we earn interest on the starting $100 and the extra $2. And if I put times 0.02, I'm going to get the same result here. So again, that's the cool part about compound interest is you earn interest on the interest that you previously earned that is now your money. And we can calculate the value each year by doing exactly that. So our starting investment times 1 plus R times the vector of 1 to the total number of years. This is just 1 to 40. So if I do this, I'm going to get a vector of different values. You can see pretty cool. We start, after 1 year, we have $102. After 40 years, we have $220. So that's pretty cool, right? Like you basically just put your money away, you put $100 away, and 40 years later, you have more than double what you put in. Hopefully that outpaces inflation, and hopefully, that the money isn't worth even less, but that's a whole nother economic consideration. In this case, you put it in and you double your money. So now let's actually look at, make a quick chart of that. I organize it into a data table, and I just do a simple ggplot where I can see, it will load on the x-axis the number of years that it's been in my account, and then the total amount of the portfolio. So after 40 years, we almost have $225. And you can see that, maybe I'll do a separate video on the power of compounding interest. You see that this line starts to it's not a straight line. It starts to increase in slope and speed up. And again, that's because the interest that you kind of have continues earning interest, and it all kind of blows up and built on each other. If I did something like 200 years, you're going to see the line really steeply start to increase and really starts to take off, which is pretty cool. Okay, so we're going back to our chart here. Now the rule of 72, which we talked about at the start of this video, that basically says if we take 72 divided by the percent return, that's the number of years that it takes about-ish for our investment to double. Okay, so what do I mean? I'm taking 72, I'm dividing by our return, which in this case is, I'm not going to divide by 0.02, I'm going to divide by 2. So 2% return. And that says in 36 years, in about 36 years, our investment should double. And if we look on this chart, that's pretty accurate, right? Here's 35, here's 36. This doubles at 35, but it's about 36, right? We hit 200, we started with 100, and at 35, 36, we double our amount to get to 200. So I'm going to add a line here. Geom V line is the same vertical line. The x-intercept is going to be 72 divided by 100 times R. R is just kind of our 2%, and we convert it. So we get to 2 instead of 0.02. And you can see, look, right, like we have our years, and it's about where kind of our portfolio crosses 200. And I'll put in a horizontal line so we can see where this doubles. Okay, so at this point we're doubled, and here's, so it's about there that the dots, it's about at the vertical line, 36 years, that the dots finally cross and actually double our original portfolio amount. So we just did this for 0.02, but let's try it for a different number. Let's try it for 0.03. So in this case, again, very close, right? Like In this case, we have 3%. So we would expect in 24 years, our investment to double. And you can see here's 24 years, and our investment doubles right about there. What if I have a really high rate of return, like 10? So in this case, we expect it to double in just 7 years. And you can see this works as well. 10 really speeds up really fast. If we have 10% return, then your $100 in 40 years is like $4,000. So it's like 40x. So that's awesome. And in just 7 years, you kind of pass this value. If you have a really, really slow, like if you just have like 0.1% return, that's where, we're going to want that to be, I'm sorry. Yeah, I think that's right. If we have 0.1%, yeah, if we have 0.1%, then it's going to take us 72 divided by 0.1, which is 720 years. And we can actually like do that on the graph if we really want to, go all the way out to 800 years. And look, it starts to break down out here, but it's these two lines cross relatively where the chart crosses. This would be brutal if you have a 0.1% return. It takes 720 years for you to double your original investment. But I think 2% is a nicer kind of example. So hopefully this makes, I don't know when I go. Hopefully this makes sense. Rule 72 divided by the interest rate, the amount of years that you expect for your investment to double. And again, because of the power of compound interest, once it doubles, it just kind of keeps doubling and doubling and speeding up faster. So hopefully you enjoyed that, and we'll see you next time.